Hey guys, today's lecture is on vector velocities, and then we may get into acceleration a little bit, depending on how much time goes by here. So, kind of like displacements, when we start to add up velocities, they get added together, but one of the components that we need to talk about before that is the fact that the difference between velocity and speed is that speed does not have a direction. So velocity has a direction. Where speed just tells you how fast you're moving, how many meters per second that you are, getting somewhere. Velocity actually tells you a direction. And because it tells you a direction, that means that we can represent it by a vector. A vector is basically just an arrow. And the direction that that arrow is pointing in tells you where the movement is occurring. And then how long the arrow is tells us the magnitude of that movement. So in this case, if this arrow was moving to the right here, and we'll say that, I'm still waiting for my new stylus to come in, we'll say that it is going that far, we'll say that's 4 to the right. So that would be like 4 meters per second we'll say that that's east. Right. If you had another, if we were going to add another one, and we'll say that one is going to the west. Then if we were to add these up, then overall you would be just going to the west, or sorry, to the east. So that would be 2 meters per second in the east direction. So the difference between speed and velocity is that velocity has a direction, whereas speed doesn't. Okay. Now, kind of like something we talked about before, I'm going to erase this. If you start adding up velocities like displacements, if you remember, displacements didn't always necessarily happen along a straight line. Well, velocities don't always happen along a straight line either. So, and there's an example in the book that gives you this as well. But we'll say you have one velocity vector that's, say, 5 meters per second there. And then you have another one that is, actually, we will say, yeah, sure. That we'll say this one is 4 in that direction. So what's the overall velocity? Like where did this thing actually go? Well, kind of like displacements, you have to do the Pythagorean theorem and figure out what the hypotenuse of the right triangle is. So that is a squared plus b squared equals c squared, where this would be 5 squared plus 4 squared equals c squared. So that's 25 plus 16 equals c squared. 25 and 16 is 41 equals c squared. And then in order to get that c to be just a c rather than c squared, you would have to take the square root of both sides. Hopefully you guys remember this from algebra. So that would just turn that into c equals the square root of 41. I'm going to take out my calculator real quick and we'll see what that is. So that would end up being 6.4. And that would be in meters per second. So the overall velocity would be 6.4 meters per second. And that would basically be in whatever this direction is, looks kind of like northeast. So that's how you would figure out velocities if you were adding them together. Right, so that's vector addition dealing with velocities. The next thing that the chapter goes into is acceleration. Acceleration's a little bit different. There are many different formulas, but the basic formula for acceleration is A. So it's small a, capital A is area. A equals V sub F minus V sub I over T, where V sub F, that F means final velocity, and the V sub I means initial velocity. So the important thing to know here, whenever you're solving one of these problems, is what was the velocity that it started off as, okay, and what is the velocity that it finished at. And as always with these types of problems, just figuring out that is the most important part of the whole thing. So we'll just do a little sample problem. We'll say that, a race car, and we'll solve for acceleration here. We'll say a race car takes off down a track, and it goes from 0 to 100 meters per second in 10 seconds. Okay, so the final velocity would be 100. The initial velocity would be 0 because it went from rest to 100. And then I said the time was 10 seconds. So 100 minus 0 is obviously 0. Sorry, is 100 because you're subtracting 0. So then you get 100 divided by 10, and that would give you 10. Now, what's the unit here? Well, so we had meters per second on top, and the bottom is seconds. So the unit that you end up with here is meters per second squared. So that basically means meters per second per second. So every second that goes along, this car is going to go 10 meters per second faster. So after 1 second, it's going 10 meters per second. After 2 seconds, it's going 20 meters per second. After 3 seconds, it's going 30 meters per second. So every second that goes by, it's going to go 10 meters per second faster. So that's what that unit means in and of itself. So that's basically today's lecture. What I'll do is I'm going to give you the guided problems for this. Give them a try. If you need to, go back to the notes for that are in the first couple pages in the sample problems, and see if you can figure out how to do that. And then the next video that I'll post will be maybe going through a couple of those problems, so you can kind of start to see exactly how this works, and hopefully you get a little bit more comfortable. This is the part of the year where some of you are going to start needing a little bit of help, and that's totally fine. That's what the office hours are for. So, come see me during my office hours, and we'll hopefully get you on the right track and get it all figured out. All right, good luck.